In this video, we would like to learn how to test hypotheses regarding the difference of two means using a matched pair designs. Before we go any further, let me quickly highlight that this last point here, please take it off. That does not apply. All right, so we continue. In this case, we are looking at two populations. We look at the average of this population, let's call it mu1, and then the average of the second population, let's call it mu2. Our interest is to compare these two values as long as there is a connection between the units in this population and the units in this population. In what kind of scenario might this be useful? Let us say that we hypothesize or guesstimate that sisters are usually more intelligent than brothers. So it means I'm interested in comparing the average performance of a brother to the average performance of the respective sister. So take note, you're going to need a matched pairs design here because for the first population, if you pick a brother, since your goal is to compare brothers to sisters, you will need to pick a respective what sister to match that brother. So this is a case of dependent sampling, and that will lead to matched pairs design for this analysis. To carry out a matched pairs design, you need the following conditions to be met. One, the sample in each of the that will be drawn from each of the populations must be obtained by simple random sampling, and the data must result from a matched pairs design experiment. Of course, that will lead to the sample data being dependent. Then the differences must be normally distributed with no outliers, or the sample size must be greater than or equal to 30. Take note that statistical inference methods based on matched pairs data use the same methods as inference on a single population mean, except that we're analyzing the differences. All right, without any further ado, let's take an example. So in this example, we are to assume that the differences we're going to get are normally distributed. Question A, we are to determine the difference, which will be each of the xi's minus yi's for each pair of data in the last column above. In other words, this sample data has been drawn from a population 1, and this sample data has also been drawn from another population 2. Our goal is to see if there is a marked difference or a significant difference between the averages of these two populations, assuming that they are selected as dependent units. So how do we get the differences? We will say each xi value minus yi value. For example, we're going to say for the first one, it is going to be 51.9 minus 53.5. We'll get the first difference. Rather than do this by hand, we can do this in Excel. So let's look at the data set in Excel. Here on your screen, you have the Excel document. So right here, I'm going to click in this cell. I'll type equal to. Then I would, right after that equal to, while the cursor is still blinking here, click on the first value. Excel will return the index of that cell, that is the identity of that cell, B2. So minus, I want the number in C2, and I will enter. So once you push the enter button, it will automatically compute it for you. Once you do the very first one, take note, the formula for the first one is B2 minus C2. You can see the formula there, and it computes it automatically for you. Then, if you wanted to repeat the same for every pair all the way to the last row, what you do is click on the first row, move your cursor. Currently, you can see that my cursor is white. I'm going to keep moving it to the edge of this cursor until it becomes black. Then I would hold down my mouse. Then I would drag all the way down, and automatically it will replicate the similar calculations. So 53.1 minus 54.6 is negative 1.5. These differences is what we want to observe. So I'm going to copy this, Control C, and I'm going to take it to StatCrunch. So here we are in StatCrunch. I'm going to close this and close this. Well, I already have the differences here, but I'm going to just overwrite this, Control V. There we go. So as it stands, I have this one. I don't want this. So let's see. Let's delete this column. Good. The next step is going back here. You have all the differences already obtained. So we're done with question 1. So our next part of the question is to compute the average. So D bar is the average of all of the differences we computed, and S subscript D is the standard deviation of all the differences. We can do this easily in StatCrunch. So let's go back to StatCrunch. We want the mean and the standard deviation of all of these differences. So you go to Stats, you go to Summary Stats. We want to compute a summary statistics or value for a column. And that column is all of the numbers in under column titled differences. So double click on differences and you want mean and hold down the control button to choose standard deviation and then compute. So you have the mean and you have the standard deviation. Done. So at this point, I have the mean of all the differences and the standard deviation here. Then for question C, we want to test that the mean of the differences is less than 0 at alpha equals 0.0 level of significance. We want to start off by stating the correct null and alternative hypothesis. So here we go. My null and alternative. Alternative is always what we want to test. We want to test that the mean of the differences is less than 0. So that would be versus the null hypothesis that it is equal to 0. Our alpha level is 0.05. And once that is stated, we can go on. So that is, let me call that step A. Step B, we want the p-value of the test. So how do we get that? To get the p-value of the test, you are going to go to StatCrunch. This is your data set here. So what we're going to do is go to Stats. You go to your T-stats, and we only have one column of differences. So you choose one sample in this case, and indicate that it is with data, because this is the raw differences here. So choose differences, and then what do we want to indicate? The null hypothesis is 0. The alternative is less than 0, according to the setup of our problem here. Then alpha is 0.05. So I am going to do show critical value, and make sure this is 0.05, and compute. Once you compute that, you have your p-value here, which is 0.01. So my p-value here is 0.01. So you want to recall the decision rule. The decision rule when you're using the p-value versus alpha approach is that if the p-value is less than alpha, you reject the null hypothesis. Otherwise, you do not. Otherwise, if the p-value is greater than alpha, you do not reject the null hypothesis, which is true in our case. The green, where we should reject, or the other color. The way I see it here, p-value here, 0.01, and alpha is 0.05. Let me check my p-value one more time. 0.01, correct, okay? 0.01, so I can see that my p-value is lesser than alpha. So here's my conclusion. Since my p-value of 0.01 is lesser than alpha, which is 0.05, based on the rule of making decisions, we reject the null hypothesis, which means this is the bad one. Let me use red, and this is the good one. So I would like to use blue here. So in this case, it means we have sufficient evidence in support of the mean difference being less than 0 at alpha level of significance. So at this point, we have sufficient evidence that mu d, or the mean difference, is significantly less than 0 at alpha equals 0.05 level of significance. The last part here tells us to compute a 95% confidence interval about the population mean differences. So to do that, go back to what you just did, go to Options, click on Edit. This time, rather than performing a hypothesis test, we would like to perform an equivalent confidence interval construction analysis. So what we do is make sure that the level of your test, let's see, if our alpha is 0.05, then the confidence level is 1 minus alpha, which is 0.95. So in this case, it means we're set here, 0.95. Make sure it shows critical values, very good, and then compute. And so in this case, the lower limit is negative 2.6165 and upper limit is negative 0.3084. So here we have the result. We have the 95% confidence interval that we got from StatCrunch, the lower limit and the upper limit there. So that completes that question. We proceed to the next page. In this question, to test the belief that sons are taller than their fathers, a student randomly selects 13 fathers who have male adult children. That means we want to make sure that they are matching pairs here. So you match each father to the adult male child. So this means you're definitely going to need to use test of means based on matched pairs design. Then she records the height of both the father and son in inches and obtains the following data. We'll see that soon. Based on that data, can we conclude that sons are taller than their fathers? Use alpha equals 0.025 level of significance. Note, a normal probability plot and box plot of the data, we're told, indicate that the differences are normally distributed with no outliers. Since that is the case, we don't need to check that anymore. So, A, which conditions must be met by the sample for this test? The following are the conditions that must be met by the sample for this test. A number of these have been specified before, so I will not bore you reading them to you. But please note them. They are very important. They can be asked on the exam, so please have them down. Then question B, we are to define the difference as x minus y and to write the hypothesis for this test. To do that, we go back to the data set itself. Here we have the data set. We're going to let the height of the father be x and the height of the son be y. So we need our differences, DIFF, and this will be equal to the first value minus the second value. Enter. And then click on the cell. Make sure you move your cursor until you come to the edge where it becomes black. Click, hold down your mouse, and then drag the other hand all the way down. And so you have 4.9. You have all of the differences here. So I'm going to drag all of this. In fact, all I just need is just this guy, the difference. I'll drag it to StatCrunch. I already have that here. So let me paste it here. Height of the father and height of the son. And then I'll go to Stats, go to T-Stats, one sample or one column with data. And I want just the difference, DIFF. And in this case, let's continue. I've gotten all my differences. I would like to next write the hypothesis for the test. To write the hypothesis for the test, all we need to note is that the null hypothesis will always be that the mean difference is 0, whereas the alternative is that the mean difference in this case is less than 0. All right, why is it less than 0? Take note, if x is that of the father and y is that of the son, what we want to test is to see if sons are taller than fathers. That means the height of sons is greater than that of fathers. So if we're saying x is for father, that means it is smaller minus larger. In this case, we're expecting smaller minus larger to be a negative number, which means it will be less than 0. That is why we are doing less than 0 here. So that is the hypothesis for the test. Then for the test statistic and the p-value, this is where StatCrunch comes to the rescue. So quickly, we go back to StatCrunch. We have already gotten the differences earlier, as we showed. Again, just to illustrate, go back to stats, go to t-statistics, one sample with data, then choose that particular difference, and we want to perform a hypothesis test. This is always equal to 0, but if you look back, your alternative should be less than 0. So let's do that. So less than 0, and then we want to show critical value. At what level of significance is this test? Let's see. At what level of significance? 0.025. Okay, so we go back 0.025 and compute. So I'm going to drag the output out here. I have the test statistic. It is 0.01946, and the p-value is 0.5076. Based on our analysis, the test statistic is this value, 0.0194, and the p-value is 0.5076. We can use the following decision rule. If the p-value is less than alpha, we reject the null hypothesis, which is universally true. So in this case, let's check if that is true. Our alpha in this question is 0.025. That came from what the question told us to use. So is our p-value in this case, is it lesser than this value? I see that 0.5, this is 0.0. So this is definitely greater. That means we are not rejecting the null hypothesis. So based on our findings, since the p-value is not lesser than the level of significance, remember, if it were lesser, we would reject the null hypothesis. But in this case, it is not lesser, so we do not reject the null hypothesis then, which means there is not sufficient evidence to conclude that sons are taller than their fathers at the alpha equals 0.025 level of significance. So we look at yet another example. In this example, we are told that a student wants to determine if there is a difference in the pricing between two stores for health and beauty supplies. She recorded prices from both stores for each of 10 different products. Assuming that the conditions for conducting the test are satisfied, determine if there is a price difference between the two stores. Use alpha equals 0.005 level of significance. Mind the number of zeros here. What type of test should be used? The correct answer to this question is a matched pairs design, a hypothesis test regarding the difference of two means using a matched pairs design. That's because for each stores, he has two stores, store 1 and store 2, you pick product A from store 1, you record the price. The same product in store 2, you record the price. So there is a dependence based on the fact that the price you picked in store 1 was for product A, so you are bound to pick that same price in store 2 for the same product. So in that case, you can match these two prices together. So it is in this sense that we mean that the correct type of test to be used here should be a test regarding the difference of two means using a matched pairs design. Then B, we would like to determine the null and the alternative hypothesis. In this case, the null will be represented by H0 and H1. If we want to just see if there is a price difference, not that one is bigger or the other is what? Lesser. Just any difference. Then you want the mean differences to be significant, not nothing. Not nothing means it becomes something, whereas this is equal to 0. Then we go to look at the data set in order to be able to use technology to calculate the value, the p-value here. So here we go. This is the data set. I already have it inside StatCrunch for us for convenience here. So I have store 1, store 2, the different products. For product 1, we'll price it in store 1 and store 2. Product B, do the same all the way to product J. Then, in order to do this, we need to compute the differences here. So if I would like, I can go back here and compute my difference. I'm going to call this DIFFR. And this will be equal to the first value minus the second value, and enter. And then again, I will drag all over here. And then with that said, I will also get the values here. I'm going to copy these differences and take it over to StatCrunch. Paste up there. There we go. And so with that, I'm going to go to Stats, go to T-Stats, one sample with data, and that data is DIFFR, and I would like to perform a hypothesis test. Going back to my notes, this is not equal to 0, so I want to make sure that is true, not equal to 0, and I would like to show the critical value. And to show the critical value, I would like to indicate what that level of significance is, 0.2 zeros after the decimal point. Please be careful with this one. So you have 0.005 and compute. And in this case, let us see. What is our p-value? These are test statistic, and these are p-value, 0.3298. That's kind of large. So p-value in this case is 0.3298. And versus my alpha. My alpha in this case is 0.005. What do I observe? To draw the conclusion, we note the decision rule, which says that if the p-value is less than alpha, we are to reject the null hypothesis. Otherwise, we do not reject the null hypothesis. In this scenario, we find that the p-value of 0.3298 is definitely greater than 0.005. In other words, this condition is not met. So since the p-value of 0.3298 is not lesser than alpha, which is 0.005, we do not reject the null hypothesis. That means there is not sufficient evidence to reject the null hypothesis because the p-value is greater than alpha.